Hello and welcome to Algebra 2, Lesson 79. In this lesson, we're going to learn about solving nonlinear systems of equations. So at this point in Algebra 2, you should be very comfortable with solving a system of linear equations in 2 variables or 3 variables using substitution, elimination, graphing, or matrix methods. Here, what we're going to do is just introduce something new. The concept is very much the same though. The only difference here is you just have to be very selective about what method you're going to use based on the situation that you're in. So the first thing that we're going to look at, we have a second degree equation here. We have x squared plus y squared equals 25. We know this is the equation of a circle. Then we have a line. So we have a linear equation here as well. So the definition of a nonlinear system just has to have one nonlinear equation involved. So if we wanted to solve this type of scenario, we're going to turn to substitution. And you can see with this linear equation, what happens is I have a y here that has a coefficient of 1. So very easily, I can solve this guy for y, and I can substitute into this kind of top equation. So the first thing I'm going to do is I'm going to label this equation up here as equation 1, and this guy right here is equation 2. So I'm going to solve equation 2 for y. So let's start with that. So I have negative 2x plus y equals 5. Very easy. I'm just going to add 2x to both sides of the equation. And this is going to cancel. So what I'll have is y is equal to, we'll have 2x plus 5. Let me erase this. Now, with substitution, we remember that we substitute in for the variable. So I'm going to substitute in for y, and I'm going to substitute in here, right? I'm not going to substitute in from where I took it from. So I'm going to take this 2x plus 5, and I'm going to plug that in right there for y. So that would give me x squared plus. I want this whole thing to be squared. I'm plugging in a 2x plus 5 there. So the quantity 2x plus 5, the whole thing needs to be squared. Then this is equal to 25. Now that we have that out of the way, once you got that concept down, it's just pretty much some simplification from that point. So we have x squared plus, I'm going to square this guy. I can use my special products formula. I know that I would take this first guy, this 2x, that term, and I would square it. 2 squared is 4, x squared is just x squared. Then plus 2 times this guy times this guy. 2 times 2x is 4x. 4x times 5 is 20x. Then plus this last guy 5 squared, which is 25. And then this equals 25. So the first thing we can do is subtract 25 away from each side of the equation. So that'll go away and that'll go away. I'll have a 0 over here. And what I'll have is x squared plus 4x squared, which is 5x squared. Then plus 20x, and this equals 0. So let me erase everything to this point. Don't need any of this. Now, how can I solve this for x? Well, we have a few different things we can do. We could use our quadratic formula, but kind of the quickest way to do this here is to factor it. I could factor out a 5x, and I could write this as x plus 4 inside the parentheses. I could say this is equal to 0. So now I can use my 0 factor property, or you could say the 0 product property, and I could set each factor equal to 0. So I could say 5x equals 0, or the quantity x plus 4 equals 0. If I solve this, I divide both sides by 5, and I get x equals 0 over here. If I solve this, I subtract 4 away from each side, and I get x equals negative 4 over here. So I'm not done. I have found out 2 solutions for x, but I don't know the corresponding y values. So one x value would be x equals 0. The other x value would be x equals negative 4. So let's erase this. All right, so if x equals 0, what is y? So I'm going to plug a 0 in for x in one of these equations. Doesn't matter which one. I'm going to pick the linear equation because it's easier to work with. So I would say negative 2 times 0 plus y equals 5. And so this is going to go away. I'll have y equals 5. So if x is 0, y is 5. Now the other scenario occurs when x equals negative 4. So we'd have negative 2 times negative 4 plus y equals 5. Negative 2 times negative 4 is positive 8. So 8 plus y equals 5. We will subtract 8 away from each side of the equation. This cancels. we'll have y equals 5 minus 8 is negative 3. So if x is negative 4, y is equal to negative 3. Now, I'm not going to do this in every video, but I do want you to understand that you should check these solutions and make sure they work in each equation. So if x equals 0, y equals 5, that's the ordered pair 0, 5. Then if x equals negative 4, y equals negative 3, that's the ordered pair negative 4, negative 3. So in solution set notation, put 0, 5 and negative 4, negative 3. All right, so let's check these guys real quick. So I'm going to check 0, 5 in each one real fast. So 0 squared plus 5 squared equals 25. We know that works. Then what about here? If I had 0 here and 5 here, we know that works as well, right? This would go away. You'd have 5 equals 5. All right, so this guy is a solution for both. This one checks out. What about negative 4, negative 3? So negative 4 squared plus negative 3 squared equals 25. Negative 4 squared is 16. Negative 3 squared is 9. 16 plus 9 is 25. So it does work there. All right, let's check it in the last one. So negative 2 times negative 4 would give me 8. So I would have 8 plus negative 3 equals 5. We know that's true. So this does check out in each one as well. All right, so I'm not going to check each one moving forward. I've already checked these. It's something you can do on your own for practice. I just really recommend you check things, especially when you're on a test and you're trying to get all the credit that you can. Now, I want to show you something before we kind of move on. I've graphed the circle and I've graphed the line on the coordinate plane, so you can see that there's an intersection between the circle and the line at these 2 points. All right, so we can see we have our circle here. And again, this represents x squared plus y squared equals 25. We see we have our line. Again, this is negative 2x plus y is equal to 5. And we can see that this point right here, 0, 5, exists on both of the graphs, right? It exists on the graph of the line, and it exists on the graph of the circle. So we can see that it satisfies both equations. And the same thing happens here. Negative 4, negative 3, this point is on the graph of the circle. It's also on the graph of the line. All right, for the next example, we'll see the exact same concept. We have a second degree equation and a linear equation. So we have x squared plus y squared plus 18x minus 2y minus 18 equals 0. We have 2x plus y minus 3 equals 0. So this is equation 1 and this is equation 2. Now, what I'm going to do again is solve the linear equation, equation 2, for one of the variables. In this case, I'm just going to solve it for y again because there's a nice easy coefficient of 1 there by y. So I would subtract 2x away from each side, and I would add 3 to each side. And that would give me y is equal to negative 2x plus 3. So once I've done that, I can then plug in for y in this equation up here. So I'm going to plug in here, but now also here. So this problem is going to be a little bit more tedious because there's more stuff to do. So I'll end up with what? I'll have x squared plus, again, plugging in for y, I'll have this quantity negative 2x plus 3. This is squared plus 18x, then minus 2 times, again, I'm plugging in for y, so this negative 2x plus 3, and then minus 18. Okay, and then this equals 0. All right, so now we have that out of the way. Let me erase this, and then I'll just slide this up. All right, so now we just have some simplifying to do. So we have x squared plus, if I use my special products formula there, I would square negative 2x, that would be 4x squared. And then I would do 2 times negative 2x times 3. If you think about 2 times negative 2, that's negative 4. Negative 4 times 3 is negative 12. So you'd have negative 12 times x, or minus 12x. And then I'd have 3 squared, which would be 9, so plus 9. Then I have this plus 18x. Then I'm going to distribute this negative 2 to each term here. So negative 2 times negative 2x is plus 4x. And then negative 2 times 3 would be minus 6. And then we have minus 18, and then this equals 0. All right, so what can we combine here? Well, these are like terms, these are like terms, and then these are like terms there. All right, so x squared plus 4x squared would be 5x squared. Negative 12x plus 18x is 6x. And then 6x plus 4x is 10x. So plus 10x. Then we have 9 minus 6, which is 3. And then 3 minus 18 would be negative 15. And then this equals 0. All right, so let me erase everything. Let's slide this up. So most of you will notice that you could divide both sides of the equation by 5 here. And that'll make the numbers you're working with a little smaller. So you'll have x squared plus 10 over 5 is 2, so 2x, and then minus 3, and this equals 0. So I can solve this by factoring. I know the left part here would factor into what? So give me two integers that sum to 2 and multiply together to give me negative 3. Well, I could do plus 3 and minus 1. 3 minus 1 is 2. 3 times negative 1 is negative 3. So x plus 3 and x minus 1, and this equals 0. All right, let's erase all this, and we'll bring this up. So I'm going to set these two factors equal to 0, and I'm going to solve. I'll have x plus 3 is equal to 0, or x minus 1 is equal to 0. Of course, these are very easy to solve. I just subtract 3 away from each side of the equation here. I get x equals negative 3. Over here, I add 1 to each side of the equation. I get x is equal to 1. So I know that we have x equals negative 3, and then we have x equals 1. So let's erase everything. And again, I just want to plug in to one of the equations and see what my value is for y for each given x value. Now, the linear equation is much easier to work with. If you want to plug into equation 1, you can. I recommend you end up doing that just as a check with the solutions that you get. So if x is negative 3, I'd have 2 times negative 3 plus y minus 3 equals 0. This would be negative 6 plus y minus 3 equals 0. Negative 6 minus 3 would be negative 9. So I would have y minus 9 equals 0. Add 9 to each side of the equation. I get y is equal to 9. So if x is negative 3, y is equal to 9. All right, let's try the other scenario now. So what about when x is 1? So 2 times 1 is 2. So you'd have 2 minus 3, which would give me negative 1. So you'd have y minus 1 equals 0. Add 1 to each side of the equation. You get y is equal to 1. So as our solution set goes, we'll have the ordered pair negative 3, 9. And we'll have the ordered pair 1, 1. Now I'm not going to go through and check these, but I recommend that you do. I already know they work because when I set up these problems, I did check them. All right, let's look at a different scenario now. So when you see two second-degree equations, what you want to use now is elimination. So let's say we see something like 2x squared plus 2y squared minus 5x plus 20y equals 0. And then 7x squared minus 2y squared minus 49x minus 20y equals 0. So I'm going to call this equation 1 and this equation 2. Now, most of the problems you're going to see in an Algebra 2 course will set up to where you can just add the equations right away, and you'll have one of the variables be eliminated. So if I add equation 1 and equation 2 together, that'll give me equation 3. So 2x squared plus 7x squared would give me 9x squared. 2y squared minus 2y squared would give me 0y squared. Or we could just say 0. And then negative 5x minus 49x, we'll say that's minus 54x. And then 20y minus 20y, let's say this is plus 0y, or again, this is 0. And then this equals 0. So what I'm left with now is 9x squared minus 54x, and this equals 0. So this is something I can solve very quickly using factoring. I can factor out a 9x, and I'll have x minus 6 inside the parentheses. This equals 0. Let me erase all of this. We don't need any of this information anymore. And I will just scooch this up. 9x is a factor, so I'm going to set that equal to 0. Then or the quantity x minus 6, that's a factor. I'll set that equal to 0. Very, very easy equations to solve. Divide both sides of the equation by 9 here. We see x is equal to 0. Here I can add 6 to each side of the equation. I'll see that x is equal to 6. So let me erase everything. And the substitution part here is a little bit more tedious than it was before because you don't have a linear equation anymore. All right, so let's see what happens when x equals 0. So I'm going to go back and label this as 1 and 2. And I'm going to plug in a 0 for x in equation 1. So 2 times 0 squared plus 2y squared minus 5 times 0 plus 20y is equal to 0. All right, so this is gone and this is gone. So basically what I have is 2y squared plus 20y is equal to 0. Now what I can do is I can divide each side of the equation by 2. I can make those numbers smaller, so that cancels. I'll have y squared plus, this cancels with this and I have 10, so 10y, and this equals 0. Let me erase all this, and we'll slide this up. Let's get some room. I can solve this by factoring. If I factor out a y, I would have y plus 10 inside the parentheses. This equals 0. So one of the solutions here would be that y is equal to 0. The other solution would be y plus 10 equals 0. We know we could subtract 10 away from each side of the equation, and that would give me that y is equal to negative 10. So the solution here, when x equals 0, there's two different y values that's kind of partnered up with that. So in other words, you'd have the ordered pair 0, 0, but you'd also have the ordered pair 0, negative 10. So let me kind of write this over here. X equals 0, y equals 0. Then you also have x equals 0, y equals negative 10. Now let's see what happens when x equals 6. So if x equals 6, again, I'm just going to plug into equation 1. The numbers are a little smaller, so it's easier to work with. So we'd have 2 times 6 squared plus 2y squared minus 5 times 6 plus 20y equals 0. So 6 squared is 36. So 2 times 36 is 72 plus 2y squared. Negative 5 times 6 is negative 30. So minus 30, then plus 20y, and this equals 0. So what is 72 minus 30? It's going to give us 42. So I can just get rid of this and just put this as 42 over here. Then I can subtract 42 away from each side of the equation. So this is going to go away. I'll have 2y squared plus 20y is equal to negative 42. All right, so let's erase all this, and I'll bring this back up. All right, so I'm going to divide each side of the equation by 2. So this will cancel with this, and I'll have y squared. Then plus, this will cancel with this, and I have 10. So plus 10y. This equals, this cancels with this. So I know it's negative. 42 divided by 2 is 21. So y squared plus 10y equals negative 21. So what I can do there, I can add 21 to each side of the equation. I'll have y squared plus 10y plus 21 equals 0. Now this is factorable, so I can solve it that way. Let's just slide this up. All right, so what does this factor into on the left side? Give me two integers whose sum is 10 and whose product is 21. It's easy, 7 and 3. So y plus 7 and y plus 3. So we know the solutions here. We would set y plus 7 equal to 0. Then we would also set y plus 3 equal to 0. Over here, I would subtract 7 away from each side of the equation. I would get y is equal to negative 7. Or over here, I'd subtract 3 away from each side of the equation, and I'd find that y is equal to negative 3. So if x is 6, y could be negative 7. Or if x is 6, y could be negative 3. So you have x equals 6, y equals negative 7. You have x equals 6, y equals negative 3. All right, so let's erase all this. All right, so our solution set here, we're going to have the ordered pair 0, 0. We're going to have the ordered pair 0, negative 10. We're going to have the ordered pair 6, negative 7. And then we'll have the ordered pair 6, negative 3. All right, let's take a look at one more of these. So we have 4x squared plus 2y squared minus 29x minus 8y plus 6 equals 0. We have 7x squared minus 2y squared minus 37x plus 8y minus 6 equals 0. So let's call this equation 1 and this equation 2. Two second-degree equations. And again, in your book or whatever you're using to kind of study this, especially in Algebra 2, they give you these easier problems where it's kind of set up where these are opposites and these are opposites. So I can add the two equations right now, and I can basically eliminate y. So we're going to use elimination. 4x squared plus 7x squared for equation 3 would give me 11x squared. These would be eliminated. These would be eliminated. Negative 29x plus negative 37x would be negative 66x. And then 6 minus 6, that's gone. So this just equals 0. So the first thing is I can divide both sides of this equation by 11 and make everything smaller. This would be x squared minus 6x equals 0. So let me erase this, and I'll slide this over. Of course, we can solve this guy by factoring. If I factor out an x, I'll have x minus 6 inside the parentheses. We set this equal to 0, and we say that x could be 0, or x could be what? If I set x minus 6 equal to 0, I know the solution would be positive 6. So x could be 0, or x could be 6. All right, so let's erase everything, and I'll keep this here for now. I'll kind of slide it over just a little bit. So what happens when x is 0? Let's just pick, I don't know, equation 1 looks a little bit easier. Let's pick equation 1 to work with. So if x is 0, we'll have 4 times 0 squared plus 2y squared minus 29 times 0 minus 8y plus 6 equals 0. So we know that this is going to go away, and this is going to go away. I'll basically have 2y squared minus 8y plus 6 equals 0. Now, I can divide each side of the equation by 2 and make that a little easier. So y squared minus 4y plus 3 equals 0. I can factor this, y and y. So give me two integers whose sum is negative 4 and whose product is 3. You could do negative 3 and negative 1. So minus 3 and minus 1. So I could set each factor here equal to 0. So you'd have y minus 3 equals 0, and then you'd have y minus 1 equals 0. Of course, the solution to this one would be that y equals 3. The solution to this one would be that y equals 1. If x is 0, y is equal to 3, or it's equal to 1. So we're going to set this up over here, and I'll just say we have the ordered pair 0, 3. We also have the ordered pair 0, 1. All right, so let's get rid of that. All right, now let's see what happens when x equals 6. So I'm going to go into equation 1 again, and we'll say 4 times, you'll have 6 squared, plus 2y squared, minus 29 times 6, minus 8y, plus 6, and this equals 0. So 6 squared we know is 36. 4 times 36 is 144. So let me erase this and just put 144. 29 times 6 is 174. So let me put minus 174. And we know that 144 minus 174 is negative 30. So let me just put negative 30, and then we're adding 6, so that's negative 24. So I'll put negative 24 back here. So what I'm left with is 2y squared minus 8y minus 24 equals 0. So let me erase this, and we'll kind of scooch this down. Now, one thing I can do is I can divide everything by 2. So this would cancel. I'd have y squared. This would cancel with this and give me negative 4. So I'd have minus 4y. This would cancel with this and give me negative 12. So minus 12. And this would equal 0. Now, can I solve this by factoring? Yes, I can. Let me erase this real quick. And I'll slide this guy up. So I can factor the left side here. This is y, this is y. Give me two integers that sum to negative 4 and multiply together to be negative 12. Well, of course, you could do negative 6 and positive 2. So we know the solutions here would be that y equals 6 or y equals negative 2, right? If I set each one of these factors equal to 0. So y equals 6 or y is going to equal negative 2. All right, so let's erase this. And so our ordered pairs would be 6, 6, and then also 6, negative 2. So in solution set notation, we'll say we have 0, 3 as a solution, 0, 1 as a solution, 6, 6 as a solution, and 6, negative 2 as a solution.